Okay, we're going to talk about a different kind of loop this week. We're going to talk about a while loop. But first, I want to look at last week's application that we did. We used this for a demo. And it was an application using a for loop. And the for loop began by initializing a variable. In this case, I, and then its condition involved I, and then it updated I until something happened that I no longer met the condition, and that's when the loop stopped. So we used it for this little countdown application. So we're going to start out talking about a while loop by converting this for loop to a while. Now, I did notice some people on their homework, on the lab work last week, used different variables in here, and that's not really how a for loop was meant to be. So you initialized the for loop variable outside of the loop itself, and that kind of defeats the option, defeats the benefits of using a for loop. And we're going to see that because we're going to change this for loop into a while loop, and it's going to have all the same conditions, all the same elements, I should say, that the for loop had. So we had to initialize a variable to use here. We had to have some kind of condition to be evaluated every time the loop runs, and then we had to have some way to update the loop. So we're going to come over here and we're going to do a while loop to do the same project. We're going to do a blast off that counts from 10 down to 1. The reason we counted backwards on this loop is because it was a countdown. That's how countdowns work. Some people also used for their multiplication tables, they counted backwards, even though the example showed the count going forwards. You need to think about the project you're doing. Your goal is not to copy the code that I have here. It's to use the principles we learned. Just because this one counted backwards doesn't mean yours shouldn't count forwards. I showed you examples where we didn't initialize in a loop, but I showed you that the best way to do a for loop was to include all three things: the initialization, the condition, and the update. All of them inside the loop. That's what gives for loops their power. Let's go do this with a while loop. And a while loop also has a condition, and it has a body of statements that will run. Okay. But it only has one term. That while loop only has the parentheses for the condition. So while I is greater than or equal to 0 was our condition, lowercase I, was the condition we used in our loop last week. So we copied the condition in here, but we don't have the initialization and we don't have the update statement. So we have to do those separately. So I have to declare an integer called I. We'll start it at 10. I have to declare that outside the loop. Even though we can do that with a for loop, the whole point of the for loop is to do it all inside the for statement. So I initialize my variable here. And here we have a condition. And we also have to have an update somewhere. So inside our loop, let's print. Excuse me, I'm in the wrong language mind here. Systemout.println. We'll print out I. And then we'll put I minus minus. I'll put a little beside that. This is our update condition. So we have the same three things. We have an initialization of a variable, we have a condition, and we have an update. They're in three different places. So when we're doing a project like this, even though I'm showing you with a while loop, we're still getting 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Even though we can do this with a while loop, the for loop was a much better way. it put all those things in one spot, right? Nice compact code. Okay. So while loops can do the same things that for loops do, but they have a different purpose. In a for loop, we know how many times we want that loop to run. Okay. Its strength is that it can run a certain number of times. Even if we're asking the user at some point, enter how many times you want to run, and we use a variable here instead of the hard-coded number 10, it's still a known quantity. It's going to run a certain number of times when it gets there. And for loops are great for that. Using a while loop to do what we did with the for loop last week just doesn't make sense. It works, but it's not necessarily the best way to accomplish the job. When we're doing something like counting, a for loop is much better. So what is the value in a while loop? Well, a while loop is great when you don't know how many times it's going to run. Let's do an example that might be a little bit better. Let's do scanner. New scanner. We're going to make a little scanner here. And I believe that's a capital S, and this is a lowercase I. And then we have to import our scanner class. We've done that a million times by now. So I'm going to do a little scanner. And now I am going to prompt the user and say, please enter a number to multiply or Q to quit. That should work. So we'll go to our scanner, get a variable. I'm going to get, because we're giving them the option, let's do -1. -1 to quit. We'll do -1, or a number to multiply, or -1 to quit. Let's do int number equals sc.nextInt. Okay. So we're getting a number from the user. While the number is not equal to -1, we're going to do something. So as long as the user doesn't enter a -1, we're going to do something in here. What are we going to do? Let's take their number. We'll print out their number. Number, and we'll concatenate it on, times 5 equals, and then we'll concatenate onto that, their number times 5. So whatever they enter, we're going to take their number, multiply it by 5, and print it out. Let's run that. So we're going to please enter a number to multiply or -1 to quit. And I am going to put in the number 3. And notice what's happening here. 3 times 5 equals 15. That's what we wanted, but it's running over and over and over and over and over. Okay. Because nothing in here inside the loop ever updated this condition so that it became false. What I need to do inside my loop is ask them for a new number. So we're going to talk about why we did that here in a second. I'm going to ask them for a new number, and I'm not going to declare my variable again. I'm just going to call for my next int. Now let's run it again. Please enter a number to multiply by or 1 to quit. I put 3. 3 times 5 equals 15. Now it says, please enter a number to multiply or -1 to quit. Let me do 7. 7 times 5 is 35. 9. 9 times 5 is 45. 4. 4 times 5 is 20. It keeps going until I put in the number -1, and then my program ends. Maybe down here I should put thank you for playing. And I think I'm going to print a blank line in there just to make, actually I'm going to print I'm just printing a line in there to separate things. Let's run it again. 5. Please enter number 6. 6 times 5 equals 30. 7 times 5 equals 35. 1 times 5 equals 5. So it's always doing the same thing. I don't know how many times this loop's going to run. It's going to run until the user gets tired and doesn't want to multiply numbers by 5 anymore, at which point they'll stick in -1, and we call -1 a flag. That's the thing that's going to change to make this become false. All right, so a while loop is good in this case. We're going to do something in here, and I picked something really trivial. I picked something really trivial by like taking a number and multiplying it times 5 and printing it out. Okay, there's nothing complicated about that. But then I'm letting the user play as many times as they want. I don't know if they're going to do 3 times, 10 times, or 1,000 times. We don't know how long this loop is going to run. So a while loop is the right one to pick. As long as there's something inside that can update the condition to become false, and this is technically what updates the condition when they type in a number that meets the right condition, which in this case is -1, makes this become false, and the loop ends. And when we're done, it prints thank you for playing. The minute I put in -1, it came back up here. This became false. It jumped down after the loop and ran this line that said thank you for playing. All right, so while loops are good when you're checking for a condition and you don't know how long that condition is going to stay positive, stay true. So we use it when we don't know. In a for loop, we knew it was going to run 10 times, or it was going to run 100 times, or it was going to run 50 times. For loops are great for that. While loops are great for when we don't know. Now, I notice I had to do something here. I had to seed this loop. I had to ask the user for a number before I started the loop so that this condition would necessarily be true to get the loop to run the first time. After that, we kept the loop running by asking the user for the next number. So that's a technique we have to do sometimes, is we have to jump start the loop, right? We have to ask a question and then we get to ask it again inside the loop to keep the loop running. So this is something we do a lot of times for like maybe a play. Do you want to play again? While the answer is not equal to no, we keep doing the loop inside. The game is inside that loop until the person types no, they don't want to play again, and then the loop ends. All right. We'll call that it for this recording, and we'll see you in the next one.